In this video, we will walk through a hands-on Tableau desktop exercise from connecting to data all the way to building a complete interactive dashboard. This session is designed to help you understand the basics of Tableau desktop, including how to create simple visualizations and dashboards. We'll start by connecting Tableau desktop to our Excel data sources. First, we'll connect to the fact_sales Excel file. Once you select the file from your folder, Tableau will ingest the data and display it in the data source page. Before adding the other files, let's first explore what we can see after ingesting a single data source. In the upper right corner, you'll see the connection type options, Live and Extract. To simplify this, we use Live when the data needs to be real-time and the source is fast and reliable. We use Extract when performance is more important. The dataset is large, or real-time updates are not required. You'll also see a filter option, which allows us to include or exclude specific data before creating any worksheets. Below that, we can see a preview of the table containing data from fact sales. This view lets us review the fields and validate that the data was ingested correctly. When you click the drop-down menu for a field, you'll also see other available options and functions for that column. Next, we'll add the remaining dimension tables into Tableau Desktop. We'll drag in all the sheets from each dimension file and rename the sheets if necessary. For example, the DIM calendar table. To rename this sheet, simply right-click on it and select Rename. You'll notice that Tableau does not automatically define the relationship between some tables. In this case, we'll manually create the relationship by selecting Order Date from the Fact Sales table and matching it to date from the DIM calendar table. After that, we can review each relationship by clicking on the connecting lines to ensure that all joins are correct and aligned properly for accurate dashboard results. Once everything is validated, we'll proceed to creating worksheets and building the visuals for our dashboard. Now, we'll create calculated fields and begin building the visualizations for our dashboard. We'll define important metrics, including total sales, sales percent, sales estimate, quantity count, and classic and vintage grouping. The syntax for calculated fields in Tableau is very similar to SQL, which makes it easy to apply business logic directly in Tableau without modifying the original dataset. To create a calculated field, go to the Data pane, click the drop-down menu, and select Create Calculated Field. We'll now create the calculated fields we'll use throughout the dashboard. Please follow the notation as you see on the screen. Total sales equals quantity multiplied by the price. Sales percent equals the sum of quantity multiplied by the price divided by the total sum of quantity times price. Sales estimates equals sum of total sales divided by month max order, date times 12. Quantity count equals count quantity. Classic and vintage is a classification. Hence, If the product line contains cars, then we tag it as classic and vintage cars. Else we tag as other product lines, then end. These calculated fields allow us to standardize metrics and reuse them across multiple worksheets. Using these calculations, we'll create KPI cards and other visuals that will appear at the top of the dashboard. In a new worksheet, simply drag the total sales field into the blank view. After that, click the drop-down in the toolbar and select Entire View so the value is centered and fits well in the dashboard. Next, double-click the worksheet title and rename it to Total Sales. Then format it as needed. You can right-click the number, select Format, and adjust the font size, alignment, and style. You can also center the text and change the background color of the worksheet to improve the design. Feel free to explore other formatting options to enhance the look of your KPI. Then, rename the worksheet. To create the sales estimate card, simply duplicate the total sales worksheet and rename it to Sales Estimate. This saves time and keeps the formatting consistent. Next, we'll create KPI cards for order status. Just like before, drag QT count into the blank view. The additional step here is adding a filter. Drag the status field from the dim_status table into the filters pane. A pop-up window will appear. Under the General tab, select any status, then click OK. You'll see the quantity update based on the selected status. Do the same thing with the other order status. Next, we'll create a bar chart to show monthly sales. Instead of dragging fields into the blank pane, we'll use the columns and rows shelves. First, drag the order date field into the columns shelf. By default, it may show as year. Right-click the field and change it to the month level. Next, drag the sales field into the rows shelf. Tableau will automatically create a line chart. To change this to a bar chart, go to the Marks pane, click the drop-down, and select Bar. Set the view to Entire View, make the chart larger. You can also explore other visualization options by clicking Show Me in the upper right corner, where Tableau provides guidance on which fields are needed for each chart type. To show data labels, drag the Sales field to the Label option in the Marks pane. Rename the title to Monthly Sales, and hide unnecessary field labels for a cleaner look. You can also change bar colors and sizes using the color option, and enhance interactivity by adding fields to the tooltip or detail. Next, we'll create a pie chart to show the percentage of sales by product line, followed by another pie chart comparing classic and vintage cars against all other product lines. Drag total sales into the blank view. In the Marks pane, change the chart type to pie. Drag the product line field to color to create the slices. You can customize the colors using the color option. Next, drag product line, total sales, and sales percent into the label box to display values directly on the chart. Format the pie chart to match the design of the previous visuals, so everything looks consistent. Duplicate and do the same thing with the classic versus vintage car sales chart. For our final worksheet, we'll create a matrix table using parameters and calculated fields to make it dynamic. First, create a parameter by clicking the Data pane dropdown and selecting Create Parameter. Name it Category Parameter, set the data type to string, and choose List. Add the following values in order: deal size, product line, brand, product name, and status. Then click OK. Next, create a calculated field named Category using this formula. Case category parameter. When deal size, then deal size. When product line, then product line. When brand, then brand. When product name, then product name. When status, then status. End. Repeat this process for the date parameter and measures parameter. For date parameter, input year and month. Then use this calculated field. case date parameter. When year, then STR, order date. When month, then date name, month, order date, end. For measures parameter, input quantity, sales and average sales. Then use this calculated field. If measures parameter equals total sales, then total sales. Else if measures parameter equals quantity, then sum quantity. Else if measures parameter equals average sales, then AVG sales, end. Now to create the matrix table, drag date year month to the columns shelf, category to the rows shelf, and measure to the label option in the marks pane. Set the view to fit width, hide the title and field labels, and format the table as needed. Finally, right-click each parameter and select Show Parameter. These controls will appear on the right side and allow users to dynamically change the contents of the matrix. Try adjusting the parameters to confirm everything works correctly. With all worksheets complete, we're now ready to design and assemble the dashboard. So here is the sample dashboard that we will use as a reference while creating our own dashboard. First, let's set the dashboard size. Under the Size section, change it from Automatic to Fixed Size, then select a desktop preset. I'll choose here the PowerPoint 1600 by 900 pixels. On the left-hand side, make sure that the floating option is selected instead of tiled. We'll be using floating objects to have more control over positioning and alignment. Now, let's start building from the top section. We'll first add the header elements. Drag the image or logo worksheet and position it in the upper left corner. Next, add a text object in the center and type in the title, Sales Dashboard. Adjust the font size and alignment so it stands out clearly. In the upper right corner, add another text or button-style worksheet for navigation, such as Tabular View or Dashboard View. Next, we'll move on to the KPI cards row. Drag each KPI worksheet onto the dashboard one by one. Since we're using floating, we'll manually align them side by side in a single row. Use the layout pane to adjust width, height, and padding so all KPI cards are evenly spaced and consistent. Once the KPI section is in place, we'll add the monthly sales bar chart. Drag the worksheet into the middle section of the dashboard and resize it to span almost the full width. This will serve as the main visual focus of the dashboard. Below that, we'll add the two pie charts. Drag the product percent sales pie chart to the left and the classic and vintage cars versus other product lines pie chart to the right. Resize and align them so they appear balanced and symmetrical. Next, we'll create the tabular view section. Now let's add the parameter controls. Make sure the date parameter, category parameter, and measures parameter are shown, then float them at the top of the table section. Align them horizontally so users can easily interact with the table and customize the view. Drag the matrix table worksheet to the lower portion of the dashboard. Resize it to fit the available space and ensure the table is readable. At this point, let's do some final cleanup. Hide unnecessary worksheet titles, adjust spacing using the layout pane, and make sure fonts and colors are consistent across the dashboard. Floating layouts give us flexibility, but alignment is key, so take a moment to fine-tune positioning. Finally, test the dashboard. Click on KPI cards, change parameter values, and interact with the charts to ensure everything updates correctly. Once everything is working as expected, the dashboard is complete and ready for presentation.